Hello there, and welcome to a journey into one of nature's most gentle kingdoms. Tonight, we drift into the quiet world of mushrooms, where silence speaks volumes and the smallest creatures perform the grandest acts of kindness. This is a place where time moves differently, where patience is rewarded, and where the most profound mysteries unfold, not with drama, but with the softest whisper of spores on the wind. If you find yourself here seeking rest, seeking calm, or simply curious about the tender side of nature, you have found the right place. Tonight we explore not the fierce or the fast, but the peaceful, the cooperative, the beautifully interconnected world that exists mostly unseen beneath our feet and all around us. These are stories that invite you to slow down, to breathe deeply, and to discover how the humblest organisms on Earth have mastered the art of living in perfect harmony. As we begin this gentle exploration, feel free to close your eyes and simply listen. Let these peaceful facts about mushrooms carry you toward rest, toward wonder, or wherever your mind wishes to wander. There is no urgency here, no need to remember every detail. Simply allow yourself to be present with these quiet marvels that have been perfecting the art of serenity for hundreds of millions of years. In the depths of ancient forests, where sunlight filters through countless layers of leaves and the air itself seems to hold its breath, there exists a network more vast and more quietly powerful than any human creation. This is the realm where mushrooms reveal their first peaceful secret. They are not solitary beings competing for resources, but gentle architects of the most cooperative system nature has ever devised. Beneath every footstep you take in a forest, thread-like structures called mycelium weave through the soil like nature's own internet. These delicate filaments, finer than silk and more patient than time itself, connect tree to tree, plant to plant, creating what scientists have come to call the wood wide web. It is a network built not on competition or dominance, but on the revolutionary principle that sharing leads to thriving. Through this underground web, trees communicate in a language older than words. A Douglas fir injured by insects sends chemical signals through the fungal network to a nearby pine tree. The message travels silently, peacefully, and the pine responds by producing defense compounds to protect itself from the same threat. This is not mere survival. This is community care elevated to an art form, orchestrated by mushrooms that ask for nothing more than to facilitate this ancient conversation. The mycelium network operates with the patience of geological time and the precision of the most sophisticated technology. When a young seedling struggles in the shadow of giants, the network responds, nutrients flow through fungal highways, from trees with abundance to those in need. Phosphorus travels from an oak with deep roots to a maple reaching toward distant light. Carbon moves from a sun-bathed birch to a pine standing in perpetual shade. The mushrooms serve as both the roads and the traffic controllers of this peaceful economy, ensuring that no member of the forest community is forgotten. This cooperation extends beyond mere resource sharing. The fungal network acts as the forest's memory, storing information about seasonal changes, environmental threats, and the location of resources. When drought comes, the network helps trees prepare by signaling them to conserve water. When nutrients become scarce, it redirects the flow to maintain the health of the entire community. Through it all, the mushrooms work tirelessly and silently, never demanding recognition for their role as the forest's most dedicated peacekeepers. As we move deeper into the mushrooms' world of peaceful wonders, we discover creatures that have turned the very act of existing into meditation. There are fungi that glow with their own gentle light, creating lanterns in the darkness that guide nothing more urgent than our sense of wonder. These bioluminescent mushrooms emit a soft, greenish glow that appears as the sun sets and dims as dawn approaches. They are nature's nightlights, steady and reassuring, like the breathing of the earth itself made visible. The foxfire fungus and the jack-o'-lantern mushroom transform the forest floor into a constellation of earthbound stars. Their light requires no fuel but life itself, no maintenance but the simple act of being alive. Unlike the harsh glare of artificial illumination, their glow is soft enough to preserve the night's mystery, while providing just enough light to remind wanderers that even in darkness, beauty persists. Scientists believe these mushrooms glow to attract insects that will carry their spores to new locations. But there is something profound in how they accomplish this goal. Rather than demanding attention with bright flashes or urgent signals, they simply exist in their gentle radiance, trusting that their quiet light will be enough. In a world that often mistakes loud for important, these mushrooms demonstrate that the most essential communications happen in whispers. The peaceful mathematics of mushroom growth reveals another layer of their serene wisdom. Many fungi follow the Fibonacci sequence in their development, creating spirals and patterns that appear throughout nature, from nautilus shells to galaxy formations. This is not coincidence, but evidence of an underlying harmony that mushrooms have always understood. Their growth patterns reflect the same mathematical principles that create the most beautiful and efficient forms in the universe. When mushrooms release their spores into the world, they do so with a gentleness that defies our usual understanding of reproduction and survival. These microscopic seeds of future fungi are so small and light that they can be carried aloft by air currents barely perceptible to humans. On what appears to be a perfectly still day, micro breezes invisible to our senses lift spores high into the atmosphere, where they may travel kilometers before settling into new soil. There is something profoundly peaceful about this method of dispersal. The mushroom does not force its offspring into the world with violence or urgency. Instead, it releases them with complete trust in the wind's ability to carry them where they need to go. Each spore is a small act of faith, a quiet prayer sent into the moving air. Some will land nearby, others may travel vast distances, but all are released with the same gentle hope that they will find the right place to begin their own patient lives. The largest living organism on Earth is not a towering redwood or a massive whale, but a fungal network in the Blue Mountains of Oregon. This single organism spans over 2,000 acres, covering an area equivalent to more than 1,600 football fields. It has been growing steadily for at least 2,400 years, though some estimates suggest it may be as old as 8,650 years. This ancient being represents the ultimate expression of peaceful persistence. Rather than growing through conquest or aggression, it has expanded slowly and steadily, one careful connection at a time. It has witnessed the rise and fall of entire civilizations, the changing of climates, and the evolution of the forests it helps to nurture. Through it all, it has continued its quiet work of connecting, sharing, and supporting the life around it. The longevity of this organism speaks to the power of gentle consistency. In a world fascinated by rapid growth and dramatic change, this fungal network demonstrates that the most enduring success comes from patience, cooperation, and the steady accumulation of beneficial relationships. It has outlasted empires not through strength or dominance, but through its unwavering commitment to helping others thrive. Deep in the forest's embrace, we find mushrooms that have mastered the art of healing without harm. For thousands of years, cultures around the world have recognized fungi as gentle healers, organisms capable of restoring balance without the harsh side effects often associated with more aggressive treatments. The reishi mushroom, known in ancient traditions as the mushroom of immortality, embodies this peaceful approach to wellness. Reishi works not by overwhelming the body's systems, but by supporting them in their natural functions. As an adaptogen, it helps the body adapt to stress by restoring balance rather than suppressing symptoms. Its compounds work with the nervous system to promote a sense of calm and relaxation, like a wise friend offering gentle guidance rather than forceful intervention. The mushroom's approach to healing mirrors its approach to living, patient supportive, and fundamentally respectful of the body's own wisdom. The therapeutic effects of reishi extend beyond the physical realm into emotional and spiritual well-being. Traditional herbalists have long recognized that true healing addresses not just symptoms, but the whole person, and reishi's gentle influence on sleep, stress response, and overall vitality reflects this holistic understanding. In our modern world filled with urgent demands and constant stimulation, reishi offers a return to natural rhythms and peaceful restoration. Other medicinal mushrooms continue this tradition of gentle healing. Lion's mane supports cognitive function without the jittery side effects of stimulants. Turkey tail strengthens immune function while respecting the body's natural balance. Cordyceps enhances energy through supporting the body's own systems rather than providing artificial boosts. Each of these fungi approaches healing as a collaborative process, working with the body rather than against it. The peaceful nature of mushroom medicine extends to how these organisms interact with their environment. Unlike synthetic compounds that may persist in ecosystems long after their intended use, mushroom-derived medicines integrate seamlessly into natural cycles. They come from the earth and return to it without leaving harmful residues or disrupting delicate ecological balances. As we continue our gentle journey through the mushroom kingdom, we discover that these remarkable organisms have been quietly shaping our world for far longer than most people realize. Fungi were among the first complex life forms to colonize land, beginning their patient work of transforming bare rock into soil over 800 million years ago. They accomplished this monumental task not through force or speed, but through the slow, steady application of gentle acids that gradually broke down stone into the foundation for all terrestrial life. These ancient pioneers worked in partnership with the first plants to emerge from the sea, forming symbiotic relationships that allowed both organisms to thrive in the harsh conditions of early Earth. The fungi provided plants with essential nutrients extracted from rock, while the plants shared the sugars they created through photosynthesis. This cooperation laid the groundwork for every forest, every meadow, and every garden that has ever existed. The fossil record reveals evidence of giant fungal structures called prototaxites that once dominated ancient landscapes. These mysterious organisms, some reaching heights of 8 meters, were the tallest life forms of their time, standing like gentle giants in a world still learning how to be green. They represent an era when fungi were not hidden beneath the soil, but stood proudly above it, serving as monuments to the power of patient growth and peaceful persistence. Even today, mushrooms continue their ancient work of transformation and renewal. As decomposers, they break down fallen leaves, dead wood, and other organic matter, recycling the building blocks of life back into forms that can nourish new growth. This process happens without fanfare or recognition, yet it is essential for the continuation of life on Earth. Without mushrooms and their quiet work of decomposition, the world would be buried beneath layers of organic debris, unable to support the cycles of death and rebirth that keep ecosystems healthy and vibrant. The way mushrooms approach this vital task reflects their peaceful nature. They do not destroy or consume aggressively, but rather embrace and transform. They find beauty in decay, opportunity in death, and potential in what others might discard. Through their gentle chemistry, they turn endings into beginnings, completing circles that connect every living thing in an endless dance of renewal. This transformation happens through the release of specialized enzymes that break down complex organic compounds into simpler forms that other organisms can use. The process is neither violent nor hasty, but rather resembles a careful unweaving of life's tapestry, with each thread being saved and repurposed for future creations. The mushroom serves as both artist and recycler, finding ways to honor what has been while preparing for what might come next. In the quiet spaces between seasons, mushrooms demonstrate another aspect of their peaceful mastery. the art of perfect timing. They emerge when conditions align in ways that speak to an intelligence beyond our understanding, appearing seemingly overnight after rain has softened the earth and warmth has awakened dormant networks below. There is no rushing in the fungal world, no anxiety about missed opportunities or competition for prime real estate. Each mushroom appears precisely when it should, carrying within its brief visible existence the accumulated wisdom of an underground network that may have been preparing for this moment for months or even years. The patience required for this timing is profound. While the visible mushroom may live for only days or weeks, the mycelial network from which it emerges operates on timescales that dwarf human urgency. Some mycelia persist for centuries, quietly maintaining their underground communities through droughts and floods, harsh winters and blazing summers, always ready to fruit when the moment is right. This long view of existence offers a different perspective on success and achievement, one measured not in quick victories, but in sustained presence and readiness. When mushrooms do appear, they often emerge in fairy rings, those perfect circles that have captured human imagination for millennia. These rings form as the mycelium expands outward from a central point, consuming nutrients and creating new growth at the advancing edge. Over time, this creates a circle of mushrooms that grows larger each year, sometimes reaching diameters of many meters. The mathematical precision of these formations speaks to the orderly nature of fungal growth, but their appearance feels magical, as if the earth itself has drawn perfect circles to mark sacred spaces. Local folklore has long associated fairy rings with dancing spirits or otherworldly gatherings, and there is something in their perfect geometry that invites such wonder. Science explains their formation through the simple mechanics of radial growth, but this knowledge does not diminish their ability to inspire awe. They represent the intersection of natural law and natural beauty, places where the mushroom's peaceful mathematics becomes visible, poetry written on the landscape. The gentle chemistry that mushrooms employ extends far beyond their role as decomposers into realms that hint at their potential as healers of our wounded world. Certain fungi possess the remarkable ability to break down environmental toxins, transforming pollutants into harmless compounds through processes that work more like patient rehabilitation than violent destruction. These mycofiltration systems can clean contaminated soil and water without the harsh interventions typically required for environmental cleanup. In forests recovering from industrial damage, pioneering fungi arrive like gentle medics, beginning the slow work of restoration. They absorb heavy metals from polluted soil, concentrate toxins in their fruiting bodies where they can be safely removed, and gradually restore the chemical balance necessary for other life to return. This process may take years or decades, but it happens without creating additional harm or requiring energy-intensive machinery. The mushrooms simply do what they have always done: transform and integrate, finding ways to make the damaged whole again. The oyster mushroom has shown particular promise in breaking down petroleum products, slowly digesting oil spills and turning toxic waste into soil that can eventually support plant life. These fungi approach contamination not as an enemy to be defeated, but as a problem to be solved through patient chemistry. They release enzymes that can break apart the complex molecules of pollutants, metabolizing what seems indestructible into basic components that can rejoin natural cycles. This ability extends to other forms of environmental healing. Some fungi can digest plastics, slowly breaking down materials that would otherwise persist in the environment for centuries. Others can neutralize radioactive contamination, concentrating dangerous isotopes in their tissues where they become easier to manage and contain. In each case, the mushroom's approach is the same: patient, methodical, and ultimately restorative. Research into these capabilities has led to the development of mycoremediation projects around the world, where fungi are deliberately introduced to damaged ecosystems to begin the healing process. These projects require a different mindset from traditional environmental cleanup, one that values slow transformation over quick fixes and recognizes that true healing happens on nature's timeline rather than our own. The mushroom's approach to environmental challenges reflects a broader wisdom about how change happens most effectively. Rather than overwhelming problems with force or speed, fungi demonstrate the power of consistent, gentle pressure applied over time. They show us that the most intractable challenges can be addressed not through dramatic intervention, but through patient presence and the steady application of appropriate chemistry. As we delve deeper into the peaceful realm of fungi, we encounter species that have elevated the art of cooperation to extraordinary heights. The relationship between certain mushrooms and their plant partners goes beyond simple resource exchange to become something approaching telepathic communication. Trees connected to fungal networks can detect the presence of insects on distant neighbors and begin producing defensive compounds before the threat reaches them, as if the forest itself has developed a nervous system capable of transmitting danger signals across vast distances. This communication system operates through chemical messages that travel along fungal highways at speeds that would impress any telecommunications engineer. When a tree is attacked by pests, it releases specific compounds that are absorbed by connected fungi and transmitted throughout the network. Receiving trees interpret these signals and respond appropriately, ramping up their own defenses or altering their chemistry to become less appealing to the approaching threat. The sophistication of this system suggests that fungi serve as more than simple messengers. They appear to act as translators and coordinators, helping different species of plants communicate across the barriers of their individual languages. An oak tree's distress signal might be incomprehensible to a pine, but the fungal network can translate the message into chemical terms that both species understand. This translation service extends to other forms of forest communication as well. Trees can share information about seasonal changes, water availability, and nutrient distribution through their fungal partners. Young seedlings receive not just resources, but information from their elders, learning through chemical signals about the patterns and rhythms of their particular forest community. The mushrooms facilitate these conversations without inserting their own agenda, serving as neutral facilitators in the complex negotiations that keep forest ecosystems stable and thriving. The peaceful nature of this communication system becomes even more remarkable when we consider its scale. A single fungal network may connect hundreds of individual plants across many acres of forest, creating communities of unprecedented complexity and cooperation. Yet this system operates without central control or hierarchical authority. Each participant contributes according to its abilities and receives according to its needs, guided by chemical signals that promote the well-being of the whole community. In studying these networks, scientists have discovered that they exhibit properties similar to neural networks in animal brains, with information processing capabilities that emerge from the collective behavior of countless individual connections. The forest, through its fungal networks, may possess a form of distributed intelligence that allows it to respond to challenges and opportunities with remarkable coordination and efficiency. This intelligence manifests in ways both subtle and profound. Forests connected by robust fungal networks show greater resilience to disturbances, faster recovery from damage, and more efficient use of available resources. They demonstrate emergent properties that arise from cooperation rather than competition, creating systems that are more stable and productive than the sum of their individual parts. The implications of this discovery extend far beyond forest ecology into questions about the nature of intelligence, communication, and community. The mushroom network suggests that consciousness and decision-making may not require centralized control or individual awareness, but can emerge from the peaceful coordination of many simple interactions. They offer a model of intelligence based not on domination or control, but on facilitation and mutual support. As autumn arrives and leaves begin their gentle descent towards Earth, mushrooms prepare for one of their most important seasonal performances. This is the time when many species emerge from their hidden networks to participate in the great recycling that prepares the forest for winter and renewal. The timing of this emergence is exquisite, synchronized with the falling of leaves and the slowing of plant growth in ways that maximize the efficiency of nutrient cycling. The mushrooms that appear during these autumn festivals come in countless forms and colors. Each species specializes for particular aspects of the decomposition process. Some focus on breaking down fresh leaf litter, others work on fallen branches and woody debris. Still others specialize in the gradual processing of deep soil organic matter that has been accumulating for years. Together, they form teams of specialist recyclers whose combined efforts ensure that nothing valuable is wasted in the seasonal transition. The chemistry of this decomposition is remarkably sophisticated, involving enzymes that can break down some of the most complex and resistant compounds found in plant tissues. Lignin, the substance that gives wood its strength and durability, yields to fungal enzymes that few other organisms can produce. Cellulose, the primary structural component of plant cell walls, is systematically dismantled and converted into forms that other organisms can utilize. This process happens with a thoroughness that puts human recycling efforts to shame. Mushrooms can extract and repurpose virtually every useful molecule from the organic matter they process, leaving behind only the most recalcitrant compounds, which become part of the stable soil organic matter that enriches ecosystems for decades to come. The efficiency of this system has been refined over hundreds of millions of years, creating recycling networks that operate with minimal waste and maximum benefit for all participants. The peaceful nature of fungal decomposition becomes apparent when we observe how it integrates with the broader rhythms of forest life. There is no violent destruction or hasty consumption, but rather a gradual transformation that honors the complexity of what came before while preparing materials for future growth. The mushroom serves as both mourner and midwife in these transitions, acknowledging the end of one life cycle while nurturing the beginning of another. Through their patient work of decomposition, mushrooms maintain the delicate balance between death and renewal that keeps forest ecosystems healthy and productive. They ensure that the accumulated investments of photosynthesis and growth are not lost, but transformed into the foundation for future generations of plants and animals. In doing so, they demonstrate that death is not an ending but a transformation, a changing of forms that serves the continuity of life itself. The mushroom's role in this endless cycle of renewal offers profound lessons about sustainability and stewardship. They show us that true abundance comes not from taking more than we need, but from ensuring that what we use is returned to the system in forms that can nourish future growth. They model an economy based not on extraction and disposal, but on circulation and regeneration, where waste from one process becomes raw material for another. In the quiet hours before dawn, when dew forms like tiny pearls on spider webs and the air holds the promise of morning, certain mushrooms begin their most mysterious performance. These are the species that have learned to harness the ancient power of bioluminescence, creating their own gentle light in the darkness. Their glow emerges not from any external source, but from chemical reactions within their own tissues, a living lantern that burns without heat or fuel. The foxfire fungi and their luminescent cousins transform the forest floor into a constellation of earthbound stars. Their light appears as the sun fades and strengthens through the deepest hours of night, creating pathways of soft green radiance that seem to pulse with the heartbeat of the earth itself. This is not the harsh glare of artificial illumination, but something far more subtle, a glow that preserves the mystery of darkness while offering just enough light to guide the way. Scientists studying these glowing mushrooms have discovered that their light serves practical purposes, attracting insects that will carry spores to new locations and potentially deterring creatures that might otherwise consume them. Yet there is something profound in how they accomplish these goals. Rather than demanding attention with urgent flashing or aggressive brightness, they simply exist in their quiet radiance, trusting that their gentle beacon will be sufficient to achieve their purposes. The biochemistry of this luminescence mirrors the peaceful philosophy that governs all fungal existence. The reaction that produces their light involves the same luciferin compounds found in fireflies and other bioluminescent creatures. But mushrooms have refined this process to create a steady, continuous glow rather than intermittent flashes. Their light burns with the patience of stars, constant and reassuring, like a promise that even in the deepest darkness, life continues its quiet work. Walking through a forest where these luminescent fungi have emerged feels like stepping into a living dream. The soft green glow emanates from fallen logs, clusters of tiny mushrooms, and sometimes entire patches of forest floor, creating an otherworldly atmosphere that invites contemplation and wonder. The light is just bright enough to reveal the delicate structures of the mushrooms themselves, their caps and stems glowing like jade lanterns suspended in the darkness. Local folklore has long recognized something magical about these glowing fungi, with stories of fairy lights and forest spirits dancing among the luminescent mushrooms. While science has revealed the chemical mechanisms behind their glow, this knowledge does nothing to diminish the sense of wonder they inspire. They remain one of nature's most enchanting phenomena, proof that the most beautiful things often happen when we are not watching, in the quiet hours when the forest belongs entirely to itself. The cultural significance of mushrooms extends far beyond their ecological roles into the realm of human healing and spiritual practice. For thousands of years, cultures around the world have recognized certain fungi as gentle allies in the pursuit of wellness and inner peace. These relationships developed not through aggressive experimentation, but through patient observation of how mushrooms interact with their environment and careful attention to their effects on human well-being. Traditional healers have long understood that the most effective medicines work not by overwhelming the body's systems, but by supporting them in their natural functions. Medicinal mushrooms embody this philosophy perfectly, offering therapeutic benefits through compounds that enhance rather than replace the body's own healing mechanisms. They approach wellness as a collaborative process, working with human physiology rather than against it. The reishi mushroom exemplifies this gentle approach to healing. Known in ancient Chinese medicine as the mushroom of immortality, reishi has been revered for over 4,000 years as a tonic that promotes longevity and spiritual well-being. Its effects unfold slowly and subtly, supporting the body's natural stress response and promoting the kind of deep, restorative sleep that allows true healing to occur. Unlike synthetic compounds that may produce immediate but temporary effects, reishi works through patient accumulation, building benefits over time through consistent use. The compounds responsible for reishi's calming effects include triterpenes that work directly with the nervous system to promote relaxation and reduce the physical impacts of stress. These natural molecules integrate seamlessly with human biochemistry, supporting the parasympathetic nervous system that governs rest and restoration. The mushroom's approach mirrors its lifestyle, offering benefits that unfold gradually and sustainably, rather than providing dramatic short-term changes that cannot be maintained. Other medicinal mushrooms continue this tradition of gentle support. Lion's mane mushroom contains compounds that encourage the production of nerve growth factor, supporting cognitive function and neural health through the body's own regenerative processes. Turkey tail mushroom offers immune support by enhancing the activity of natural killer cells and other components of the immune system, helping the body maintain its own defenses rather than replacing them with external interventions. The wisdom embedded in these traditional uses reflects thousands of years of careful observation and patient experimentation. Ancient healers understood that true medicine should support the body's inherent wisdom rather than overriding it, and mushrooms provided perfect examples of how healing could happen through cooperation rather than conquest. This approach to wellness recognizes that health is not merely the absence of disease, but a state of balanced vitality that emerges from the harmonious functioning of all body systems. Modern scientific research has begun to validate many of these traditional applications, revealing the biochemical mechanisms through which mushrooms provide their therapeutic benefits. Studies of reishi show its ability to modulate stress hormones, support healthy sleep cycles, and enhance overall resilience to environmental challenges. Research into lion's mane demonstrates its neuroprotective properties and potential for supporting cognitive function in aging populations. Yet even as science illuminates the molecular basis of mushroom medicine, the fundamental principle remains unchanged. These fungi offer healing through patience rather than force, through support rather than suppression, through enhancement of natural processes rather than replacement of them. They teach us that the most profound changes often happen slowly and quietly, building strength from the inside out rather than imposing solutions from the outside in. The therapeutic relationship between humans and medicinal mushrooms also reflects the broader ecological relationships that fungi maintain throughout the natural world. Just as mushrooms support forest communities through nutrient sharing and communication networks, they support human communities by providing gentle, sustainable approaches to wellness that can be maintained over long periods without harmful side effects or dependency issues. This sustainability extends beyond individual health to encompass environmental and social considerations as well. Medicinal mushrooms can be cultivated using organic waste materials, turning agricultural byproducts into valuable medicines while reducing environmental impact. Their production requires minimal energy inputs and generates minimal waste, creating closed-loop systems that benefit both human health and ecological health simultaneously. In our modern world, where healthcare often focuses on acute interventions and rapid symptom relief, medicinal mushrooms offer an alternative paradigm based on prevention, support, and long-term wellness. They remind us that healing is not something that happens to us, but something that happens through us, with the support of allies who understand the art of gentle transformation. The mathematics of mushroom growth reveals another layer of their peaceful wisdom, demonstrating how nature's most beautiful forms emerge from simple rules applied with infinite patience. Many fungi follow the Fibonacci sequence in their development, creating spirals and branching patterns that appear throughout the natural world, from seashells to galaxies. This is not mere coincidence, but evidence of underlying principles that govern efficient growth and optimal resource distribution. When we observe the delicate gills beneath a mushroom cap, we see mathematical precision at work. The spacing and arrangement of these reproductive surfaces follow patterns that maximize spore production while minimizing material investment. Each gill is positioned to catch the slightest air movement, ensuring that spores can be released and carried away even in apparently still conditions. The geometry is both functional and beautiful, demonstrating that efficiency and elegance are not opposing forces, but complementary aspects of optimal design. The branching patterns of many fungi also reflect mathematical principles that promote both strength and flexibility. Like the branching of rivers or the structure of lungs, fungal networks develop through repeated division that creates maximum surface area for nutrient absorption while maintaining structural integrity. These patterns emerge naturally from the simple rule of growing toward resources while avoiding obstacles, yet they result in forms of remarkable complexity and beauty. The timing of spore release follows equally precise mathematical relationships. Mushrooms coordinate their reproductive cycles with environmental conditions in ways that maximize the chances of successful dispersal and germination. Temperature, humidity, air pressure, and seasonal cycles all factor into calculations that happen without conscious thought, but with perfect accuracy. The result is that spores are released at exactly the right moments to catch favorable winds, avoid harsh weather, and encounter optimal growing conditions. This mathematical precision extends to the microscopic level as well. Individual spores are sized and shaped according to aerodynamic principles that allow them to remain airborne for maximum distances while carrying sufficient genetic material to establish new colonies. Their surface textures and internal structures reflect engineering principles that balance weight, durability, and dispersal efficiency in ways that human designers are only beginning to understand. The beauty of these mathematical relationships lies not in their complexity, but in their simplicity. Mushrooms achieve remarkable feats of engineering and logistics through the application of basic principles repeated at different scales. They demonstrate that sophisticated results can emerge from simple rules when those rules are applied consistently and patiently over time. This mathematical foundation of fungal growth offers insights that extend far beyond biology into fields ranging from computer science to architecture. The branching patterns of mycelium have inspired new approaches to network design that optimize efficiency while maintaining redundancy. The structural principles evident in mushroom caps have influenced the development of lightweight building materials that combine strength with minimal resource use. The spore dispersal mechanisms of fungi have contributed to our understanding of fluid dynamics and aerodynamics, revealing how microscopic particles can travel vast distances through the atmosphere. These insights have applications in fields as diverse as weather prediction, pollution control, and the design of efficient ventilation systems. Yet perhaps the most important lesson from the mathematics of mushroom growth is the demonstration that complex, beautiful, and highly functional systems can emerge from peaceful processes guided by simple principles. Mushrooms achieve their remarkable capabilities not through struggle or competition, but through the patient application of natural laws that promote cooperation, efficiency, and sustainable growth. The seasonal rhythms of mushroom emergence provide another window into their peaceful mastery of timing and patience. Unlike plants that follow predictable schedules of budding, flowering, and fruiting, mushrooms appear to operate according to more subtle cues that integrate multiple environmental factors into perfectly timed appearances. They emerge not simply when conditions are favorable, but when conditions are optimal for their specific needs and purposes. Spring mushrooms often appear as the soil warms and moisture becomes available, but their timing reflects much more than simple temperature and humidity thresholds. They respond to changes in soil chemistry as organic matter begins to decompose more rapidly, to shifts in plant activity as roots begin extending and sharing resources, and to the availability of specific nutrients that become accessible as microbial activity increases with warming temperatures. Summer species demonstrate even more sophisticated timing, often appearing in waves that correspond to rainfall patterns, temperature fluctuations, and the availability of specific food sources. Some mushrooms emerge only after particular sequences of weather events, waiting for precisely the right combination of moisture, warmth, and atmospheric pressure before making their brief appearances above ground. Autumn brings the greatest diversity of mushroom fruiting, as many species coordinate their reproductive cycles with the annual leaf fall that provides abundant organic matter for decomposition. The timing of these autumn emergences reflects not just the availability of this seasonal windfall, but also the need to complete spore dispersal before winter weather makes reproduction impossible. Even winter has its mushroom specialists, species that fruit during the coldest months when competition is minimal, and their specialized adaptations give them unique advantages. These cold weather fungi often grow slowly and persist for longer periods, making the most of limited resources while other organisms remain dormant. The precision of this seasonal timing reflects the deep integration of fungi with their ecological communities. Mushrooms do not simply respond to environmental conditions, but participate actively in the seasonal rhythms that coordinate the activities of entire ecosystems. Their emergence patterns help regulate nutrient cycling, provide food resources for wildlife at critical times, and maintain the complex relationships that keep forest communities stable and productive. This integration with seasonal cycles demonstrates another aspect of mushroom wisdom: the understanding that timing is often more important than speed or intensity. By appearing at precisely the right moments, mushrooms maximize their impact while minimizing their resource investment. They show us that patience and careful observation can be more powerful than urgent action, and that the most effective interventions often involve working with natural rhythms rather than against them. The relationship between mushrooms and seasonal change also reveals their role as indicators of ecosystem health. Changes in mushroom fruiting patterns can signal shifts in climate, soil chemistry, pollution levels, and forest community structure long before these changes become apparent through other measures. Mycologists have learned to read the mushroom calendar as a sensitive barometer of environmental conditions, using fungal emergence patterns to track ecological trends and predict future changes. As we continue our gentle exploration of the mushroom kingdom, we encounter species that have elevated the art of symbiosis to extraordinary levels of sophistication and mutual benefit. These relationships go beyond simple resource exchange to become integrated partnerships, where the boundaries between individual organisms blur into collaborative entities that are more resilient and capable than either partner could be alone. The partnership between orchids and mycorrhizal fungi represents one of nature's most elegant examples of peaceful cooperation. Orchid seeds are among the smallest in the plant kingdom, containing virtually no stored nutrients to support germination and early growth. Instead, they rely entirely on fungal partners to provide the energy and materials needed to establish themselves. The fungi, in turn, receive benefits that may include access to organic compounds and favorable growing conditions created by their plant partners. This relationship requires extraordinary trust and coordination. The orchid seed must encounter exactly the right species of fungus at precisely the right time, and under optimal conditions for the partnership to succeed. The fungus must be willing to invest significant resources in supporting the orchid's early development without any immediate return. Yet when these partnerships succeed, they can persist for decades, with both partners thriving in ways that would be impossible for either alone. The specificity of these relationships is remarkable. Many orchid species can partner with only one or a few closely related fungal species, while some fungi are equally specialized in their plant associations. This coevolution has resulted in partnerships so tightly integrated that the survival of each species depends entirely on the presence of its fungal or plant partner. The relationships represent millions of years of gradual adaptation and mutual accommodation, resulting in cooperative systems of extraordinary efficiency and stability. Similar partnerships exist throughout the plant kingdom, with different levels of specialization and integration. Some trees maintain relationships with dozens of different fungal species, creating diverse networks that provide resilience against environmental changes and multiple sources of different nutrients. Other plants, particularly those in nutrient-poor environments, depend on highly specialized fungal relationships that allow them to access resources unavailable through their own root systems. The peaceful nature of these partnerships becomes evident when we consider how they develop and persist over time. There is no coercion or exploitation, but rather a gradual negotiation of mutual benefit that can adjust to changing conditions while maintaining the essential exchange relationships that benefit both partners. When resources are abundant, both partners prosper. When conditions become challenging, they support each other through the difficulties, sharing resources and information that help both survive until better times return. These symbiotic relationships also demonstrate the interconnected nature of forest communities. A single tree may be connected to hundreds of fungal partners, each of which may also be connected to dozens of other plants. The result is a web of relationships so complex that disturbances affecting one species can ripple through the entire network, while beneficial changes can similarly spread throughout the community. The study of these partnerships has revealed that cooperation may be far more important in evolution than previously recognized. Rather than viewing life as a competitive struggle where only the strongest survive, we see examples of organisms succeeding through their ability to form beneficial relationships with others. The most successful species are often those that are best at cooperation rather than competition, that can form partnerships that enhance the capabilities of all participants. This perspective on evolution and ecology offers profound insights into sustainable approaches to human communities and economic systems. Just as fungal networks create abundance through sharing and mutual support, human systems that prioritize cooperation over competition often prove more stable and beneficial for all participants. The mushroom partnerships provide working models of economies based on reciprocity rather than extraction, where success is measured not by individual accumulation, but by community resilience and shared prosperity. As dawn approaches and the forest begins its gentle transition from darkness to light, mushrooms reveal perhaps their most profound wisdom, the mastery of invisible influence. While trees reach toward the sky in obvious displays of growth and flowers announce themselves with bold colors and fragrances, fungi work their magic in realms beyond immediate perception. Their power lies not in what can be seen, but in what cannot, in the countless chemical conversations and subtle transformations that happen in spaces too small for eyes to follow. The mycelial networks that connect forest communities operate through chemical languages of extraordinary complexity and nuance. These underground conversations involve thousands of different molecular messages, each carrying specific information about resource availability, environmental threats, seasonal changes, and community needs. The fungi serve as both translators and librarians in these exchanges, storing chemical memories and facilitating communications between species that would otherwise have no way to share vital information. When a tree begins to show signs of drought stress, chemical signals travel through the fungal network faster than the visible symptoms appear above ground. Connected plants receive advance warning that allows them to begin conserving water and adjusting their metabolism before the stress becomes critical. This early warning system prevents minor challenges from becoming ecosystem-wide crises, demonstrating how peaceful cooperation can create resilience that no individual organism could achieve alone. The sophistication of this chemical communication extends to the recognition of individual plants within the network. Fungi can distinguish between different trees of the same species, directing resources preferentially to offspring, close relatives, or particularly valuable community members. Mother trees use these networks to nurture their seedlings, sending them not just nutrients, but also chemical information about how to respond to environmental challenges and opportunities. This preferential sharing creates what ecologists call nurturing networks, where experienced community members actively support the development of younger generations. The fungi facilitate these relationships by maintaining chemical profiles of different plants and directing resources according to community priorities that balance individual needs with collective well-being. The result is forest communities that become more stable and productive over time as knowledge and resources flow efficiently between generations. The chemical complexity of these networks rivals that of neural systems in animal brains, with information processing capabilities that emerge from the collective behavior of countless simple interactions. Individual fungal threads make decisions about resource allocation, growth direction, and communication priorities based on local chemical conditions. Yet these decisions aggregate into community-level behaviors that demonstrate remarkable coordination, and intelligence research into fungal networks has revealed that they can learn from experience, adjusting their responses to environmental challenges based on previous encounters. Networks that have survived droughts become more efficient at water conservation during subsequent dry periods. Communities that have experienced pest outbreaks develop faster and more effective responses when similar threats appear. This collective memory allows forest ecosystems to become more resilient over time, accumulating wisdom that helps them navigate future challenges. The peaceful nature of this learning process reflects the collaborative foundation of fungal intelligence. Rather than hoarding information or using knowledge as a competitive advantage, the networks share discoveries throughout the community. A successful adaptation developed by one part of the network quickly spreads to other areas, ensuring that innovations benefit the entire ecosystem rather than just their originators. In the understory of ancient forests, where filtered sunlight creates patterns of dancing shadows and the air moves with barely perceptible currents, certain mushrooms have developed relationships with light itself that reveal new dimensions of their peaceful mastery. These fungi have learned to capture and concentrate the sparse photons that penetrate the forest canopy, using this borrowed energy to support their own growth while creating microenvironments that benefit their plant partners. Some species develop specialized structures that act like natural fiber optic cables, channeling light from brighter areas to shaded locations where their mycelial networks need energy for growth and reproduction. Others create reflective surfaces that concentrate available light onto the root zones of their plant partners, effectively extending the reach of photosynthesis into areas where direct sunlight never penetrates. The precision of these light-gathering adaptations demonstrates the fungi's deep understanding of their forest environments. They respond to subtle changes in canopy structure, seasonal variations in sun angle, and even daily patterns of light movement as shadows shift throughout the day. Their structures adjust continuously to optimize light capture while maintaining the delicate balance necessary for their plant partnerships. This manipulation of light energy represents another form of peaceful transformation, where fungi take something abundant in one location and redistribute it to places where it becomes more valuable. They create no new energy, but rather serve as conduits that allow the forest community to make more efficient use of available resources. The process requires no force or competition, only the patient application of biological engineering principles that maximize benefit for all participants. The relationship between fungi and light also extends into their reproductive strategies. Many species time their fruiting cycles to coincide with seasonal changes in light quality and quantity, ensuring that their spores are released under optimal conditions for dispersal and germination. They read the subtle signals encoded in changing daylight patterns, using this information to coordinate community-wide reproductive events that maximize success rates while minimizing resource conflicts. Some mushrooms have developed the ability to influence the light environment around them, creating conditions that favor their own reproduction while benefiting other forest inhabitants. They may clear small areas of competing vegetation, adjust soil chemistry to favor particular plant communities, or even modify the moisture and temperature conditions that affect local light penetration. These modifications happen gradually and gently, creating positive changes that ripple through the ecosystem over time. The study of fungal light relationships has revealed that forests are far more dynamic and interconnected than previously understood. What appears to be a stable community of individual organisms is actually a constantly adjusting network of relationships where fungi serve as active managers of environmental conditions. They create and maintain the precise conditions necessary for forest communities to thrive, working with natural processes rather than against them to shape their environments in beneficial ways. As we venture deeper into the realm of fungal wisdom, we discover species that have mastered the art of chemical diplomacy, mediating conflicts and negotiations between different organisms with the skill of seasoned ambassadors. These fungi serve as neutral parties in the complex relationships that determine how forest communities share resources, resolve disputes, and coordinate responses to environmental challenges. When different tree species compete for the same nutrients or growing space, fungal mediators can facilitate negotiations that allow both parties to succeed. Rather than allowing competition to escalate into harmful conflicts, the fungi create win-win solutions by redirecting resources, adjusting growing patterns, or helping competitors specialize in different ecological niches. These interventions prevent the kind of destructive competition that could destabilize entire ecosystems. The diplomatic skills of these fungi extend to relationships between plants and their various pest and disease organisms. Rather than simply supporting their plant partners against all threats, fungi sometimes negotiate truces that allow controlled levels of herbivory or infection that actually benefit the overall health of forest communities. They understand that some stress and challenge can strengthen ecosystems, making them more resilient to future disturbances. These negotiations happen through complex chemical exchanges that can involve dozens of different species and hundreds of molecular messages. The fungi serve as interpreters and facilitators, helping different organisms understand each other's needs and find mutually beneficial solutions to shared challenges. They maintain neutrality while ensuring that agreements benefit the long-term stability and productivity of the entire community. The success of fungal diplomacy depends on their deep understanding of ecological relationships and their commitment to solutions that serve the greater good, rather than narrow self-interest. They recognize that their own long-term success depends on the health and stability of the communities they serve, creating incentives for fair and sustainable conflict resolution. This diplomatic role extends to human relationships with forest ecosystems as well. Fungi can serve as indicators of ecosystem health, early warning systems for environmental problems, and partners in restoration efforts that heal damaged landscapes. They offer models for sustainable resource management that balance human needs with ecological integrity, demonstrating approaches to land use that create abundance through cooperation rather than depletion through extraction. In the quiet corners of the forest, where old logs rest peacefully among ferns and moss, specialized mushrooms carry out one of nature's most important recycling programs. These wood-decomposing fungi have developed extraordinary abilities to break down the complex lignin and cellulose compounds that make fallen trees some of the most persistent organic materials in forest environments. Without their patient work, forests would become clogged with fallen timber that could take centuries to decompose naturally. The chemistry involved in wood decomposition requires some of the most sophisticated enzymes found in the natural world. Lignin, which gives wood its strength and durability, can only be broken down by a select group of fungi that have evolved specialized molecular machinery over millions of years. These enzymes work like biological blowtorches, breaking apart molecular bonds that resist almost every other form of biological attack. Yet despite the power of these chemical tools, wood-decomposing fungi approach their task with characteristic gentleness and patience. Rather than aggressively attacking fallen logs, they gradually infiltrate the wood structure, working from the inside out to slowly transform solid timber into soil nutrients. The process can take years or decades, but it happens without waste or environmental damage. Different species of wood-decomposing fungi specialize in different aspects of the breakdown process. Some focus on the initial softening of wood structure, others on the extraction of specific nutrients, and still others on the final conversion of woody debris into soil organic matter. Working together, these specialists create assembly lines of decomposition that maximize efficiency while ensuring that valuable nutrients are retained within the ecosystem rather than being lost to erosion or leaching. The timing of wood decomposition reflects the fungi's understanding of forest nutrient cycles and their commitment to sustainable resource management. They accelerate decomposition when forest communities need additional nutrients for growth and slow the process during periods when nutrient retention is more important. This dynamic management ensures that fallen logs serve as both immediate resources and long-term nutrient banks that can support forest communities through various environmental challenges. The microenvironments created by decomposing logs become centers of biodiversity that support countless other organisms. As fungi break down wood structure, they create spaces for insects, small mammals, amphibians, and other plants to establish themselves. The gradual transformation of logs into nurse logs that support new tree growth demonstrates how fungal recycling creates opportunities for regeneration and renewal throughout forest communities. This recycling process also plays crucial roles in carbon storage and climate regulation. As fungi decompose wood, they control the rate at which carbon is released back to the atmosphere, helping to moderate global carbon cycles. They can sequester carbon in soil organic matter for decades or centuries, effectively removing it from atmospheric circulation while making it available for future plant growth. The wood-decomposing fungi also demonstrate remarkable adaptability in their approach to different types of woody material. They adjust their enzyme production and decomposition strategies based on the species of tree, the age and condition of the wood, and the environmental conditions present at decomposition sites. This flexibility allows them to efficiently process everything from fresh windfall to ancient deadwood, ensuring that no organic resources are wasted in forest ecosystems. In the seasonal rhythms of forest life, autumn brings special opportunities for mushrooms to demonstrate their mastery of community coordination and resource optimization. As leaves begin their colorful transformation and prepare for their annual descent to the forest floor, fungi throughout the ecosystem begin preparing for one of the year's most important recycling events. The timing of this preparation reflects their deep integration with forest communities and their understanding of the precise coordination required for successful nutrient cycling. The chemical changes that trigger autumn leaf drop also signal fungi to begin producing the specialized enzymes needed for efficient leaf decomposition. Different species prepare for different aspects of the process, with some focusing on the breakdown of delicate tissue structures, while others prepare to tackle the more resistant compounds found in leaf veins and woody stems. This advanced preparation ensures that decomposition can begin immediately when leaves reach the ground, preventing the accumulation of organic debris that could create problems for forest communities. The coordination involved in autumn mushroom emergence reflects sophisticated community planning that takes into account resource availability, weather patterns, and the needs of various forest inhabitants. Early emerging species focus on the most easily decomposed organic matter, quickly releasing nutrients that can be absorbed by tree roots before winter dormancy begins. Later species work on more resistant materials, providing a steady supply of nutrients throughout the winter months when most plants are unable to actively seek out resources. The diversity of mushrooms that emerge during autumn represents one of nature's most impressive displays of specialized cooperation. Each species contributes unique capabilities to the community effort, with some excelling at processing specific types of organic matter, while others serve as connectors that facilitate resource sharing between different parts of the forest ecosystem. The result is a decomposition network of remarkable efficiency and thoroughness that ensures optimal use of the seasonal windfall of organic materials. The timing of autumn mushroom fruiting also reflects their role in supporting forest wildlife during the challenging transition into winter. Many species coordinate their emergence with the migration and preparation activities of birds, mammals, and insects, providing crucial nutrition resources at times when other food sources become scarce. This timing is not accidental, but represents millions of years of co-evolution that has synchronized fungal reproductive cycles with the needs of forest communities. The beauty of autumn mushroom displays serves purposes beyond simple aesthetics, creating visual signals that help animals locate nutritious food sources and coordinate their own seasonal activities. The bright colors, distinctive shapes, and strategic positioning of many species function as part of the forest's communication system, conveying information about resource availability and seasonal timing to community members who have learned to read these natural signals. The chemical interactions between autumn mushrooms and their environment create cascading effects that influence the behavior and distribution of countless other organisms. Decomposing fungi release compounds that attract beneficial insects, deter harmful pests, and modify soil chemistry in ways that prepare growing sites for next year's plant growth. These chemical signals help coordinate the complex seasonal transitions that allow forest communities to successfully navigate the challenges of winter and emerge ready for spring renewal. As winter approaches and the forest prepares for its season of quiet rest, certain mushrooms reveal their mastery of the most challenging survival strategy of all: thriving in scarcity. While most organisms respond to winter's limitations by entering dormancy or dramatically reducing their activity levels, these cold-adapted fungi have found ways to maintain their essential community functions. Even under the harshest conditions, winter mushrooms demonstrate remarkable biochemical innovations that allow them to remain active at temperatures that would shut down most biological processes. They produce specialized proteins that prevent ice crystal formation in their tissues, maintain cellular membranes that remain flexible in extreme cold, and adjust their metabolism to operate efficiently with minimal energy inputs. These adaptations allow them to continue their vital work of decomposition and nutrient cycling throughout the winter months. The appearance of mushrooms fruiting through snow represents one of nature's most inspiring examples of persistence and dedication to community service. These hardy fungi continue their recycling work even when most of the forest community has withdrawn into winter dormancy, ensuring that nutrient cycling continues and that resources remain available for the few organisms that remain active during the cold months. The species that fruit during winter often specialize in processing organic materials that other fungi cannot handle efficiently, focusing on resistant compounds and challenging substrates that require specialized biochemical approaches. By working on these difficult materials during the quiet winter months, they prepare resources that will become available for spring growth when the rest of the forest community awakens from dormancy. Winter fungi also serve as crucial food sources for the animals that remain active during the cold months. Their emergence provides nutrition for overwintering birds, small mammals, and insects that depend on these resources for survival. The timing and location of winter mushroom fruiting often reflects their understanding of animal movement patterns and nutritional needs during the challenging winter period. The persistence of fungal activity during winter demonstrates their fundamental commitment to community well-being over individual comfort or convenience. While they could easily enter dormancy like most other organisms, these fungi continue their essential work because they understand that community health depends on the maintenance of basic ecosystem functions throughout all seasons. The study of winter-active fungi has revealed that forest ecosystems are far more dynamic during winter than previously understood. Rather than being periods of complete dormancy, winter months involve ongoing processes of resource transformation, community maintenance, and preparation for spring renewal. The fungi serve as the active agents that maintain ecosystem function during these apparently quiet periods. The biochemical innovations developed by winter-active fungi have applications that extend far beyond forest ecology into fields ranging from food preservation to biotechnology. Their ability to function efficiently at low temperatures while maintaining cellular integrity offers insights that could revolutionize approaches to cold storage, winter agriculture, and the development of freeze-resistant biological systems. As our gentle journey through the peaceful kingdom of mushrooms continues, we encounter perhaps their most profound gift to the world: the demonstration that true intelligence can emerge from cooperation rather than competition, from patience rather than aggression, from facilitation rather than domination. The fungal networks that connect forest communities represent working examples of collective intelligence that achieves remarkable results through the coordination of countless simple interactions. The decision-making processes of fungal networks operate without central control or hierarchical authority, yet they demonstrate remarkable consistency and effectiveness in responding to environmental challenges and opportunities. Information flows freely throughout the network. Decisions emerge from collective input, and resources are allocated according to community needs rather than individual power or status. The result is a form of distributed intelligence that appears more stable and adaptable than systems based on centralized control. The learning capabilities of fungal networks demonstrate that memory and adaptation can exist at the community level, with knowledge being stored and retrieved through chemical signals that persist in the network structure itself. Experiences become part of the collective memory that guides future decisions, creating communities that become wiser and more resilient over time. This community-level learning allows forest ecosystems to adapt to environmental changes while maintaining their essential functions and relationships. The problem-solving abilities of fungal networks extend to challenges that would require conscious planning and coordination in human systems. They can redirect resources to address local problems, reorganize network structure to maintain connectivity when individual components fail, and coordinate community-wide responses to large-scale disturbances. These capabilities emerge naturally from the application of simple rules about resource sharing and communication that are followed consistently throughout the network. The efficiency of fungal resource distribution systems rivals that of the most sophisticated human logistics networks, yet operates without central planning, regulatory oversight, or administrative bureaucracy. Resources flow automatically to where they are most needed. Excess capacity is shared with community members facing challenges, and waste is minimized through continuous recycling and reuse. The system maintains itself through the mutual benefit that participants receive from cooperation rather than through external enforcement or regulation. The resilience of fungal networks demonstrates how distributed systems can maintain function even when individual components are damaged or destroyed. The loss of specific fungi or plant partners triggers automatic responses that reroute resources, establish new connections, and maintain community function until damaged components can be replaced or repaired. This resilience emerges from redundancy and flexibility built into the network structure, rather than from defensive measures or protective barriers. The cooperative principles that govern fungal networks offer insights that could transform human approaches to organization, resource management, and community development. They demonstrate that complex coordination can emerge from simple rules applied consistently, that intelligence can be collective rather than individual, and that the most sustainable systems are those based on mutual benefit rather than competitive advantage. The study of fungal intelligence has begun to influence fields ranging from computer science to urban planning, offering new approaches to network design that optimize efficiency while maintaining resilience. The principles of distributed decision-making, resource sharing, and collective learning observed in fungal communities provide models for human systems that could be more adaptive, sustainable, and equitable than traditional hierarchical approaches. As we draw near to the conclusion of our peaceful exploration, we find ourselves in the presence of perhaps the most profound mystery of the mushroom kingdom: the question of consciousness and awareness in organisms that have no brains, no nervous systems, yet demonstrate behaviors that suggest forms of intelligence and intentionality that challenge our understanding of what it means to know and choose and remember. The fungal networks that connect forest communities exhibit properties that in animal systems we would associate with consciousness. The ability to process information, make decisions, learn from experience, and respond creatively to novel challenges. Yet fungi accomplish these feats through mechanisms entirely different from those used by animals, suggesting that consciousness itself might be far more widely distributed in nature than we have previously imagined. The communication systems of fungi demonstrate clear evidence of information processing and decision-making that extends beyond simple chemical reactions to include what appears to be evaluation, planning, and strategic thinking. Networks can assess multiple options, weigh potential outcomes, and choose courses of action that optimize long-term benefits for the community, rather than immediate gains for individual participants. The memory capabilities of fungal networks suggest forms of temporal awareness that allow them to integrate past experiences with current conditions to predict future needs and opportunities. They can remember the locations of valuable resources, the timing of seasonal cycles, and the patterns of environmental disturbance that affect community well-being. This temporal integration requires forms of information storage and retrieval that parallel memory systems in animal brains. The creative problem-solving abilities of fungi reveal forms of flexibility and innovation that suggest something approaching imagination or creativity. When faced with novel challenges or unprecedented combinations of environmental conditions, fungal networks often develop new strategies and approaches that had no precedent in their previous experience. This capacity for innovation suggests forms of cognitive flexibility that extend beyond programmed responses to include genuine creativity. The social behaviors of fungi demonstrate forms of cooperation, reciprocity, and altruism that suggest emotional or ethical dimensions to their decision-making processes. Networks consistently prioritize community well-being over individual advantage, share resources with struggling members even when doing so involves personal cost, and maintain cooperative relationships even when competitive strategies might provide short-term benefits. The aesthetic dimensions of fungal behavior suggest forms of awareness that extend beyond purely functional considerations to include something approaching appreciation for beauty, harmony, and elegance. The mathematical precision of their growth patterns, the artistic quality of their fruiting displays, and their apparent preference for solutions that are not only effective, but also beautiful suggest forms of consciousness that value aesthetic as well as practical considerations. The spiritual traditions of many cultures have long recognized mushrooms as beings possessed of wisdom, consciousness, and spiritual significance that transcends their material forms. These traditions suggest that fungi may serve as bridges between different levels of reality, facilitating forms of communication and understanding that operate beyond the boundaries of ordinary consciousness. The scientific study of fungal consciousness remains in its infancy, but early research suggests that we may need to fundamentally revise our understanding of awareness, intelligence, and even consciousness itself. The fungi remind us that mind and intelligence may be properties that emerge whenever information is processed, decisions are made, and learning occurs, regardless of the specific biological mechanisms involved. As we prepare to rest in the gentle embrace of these revelations, we carry with us the profound peace that comes from recognizing our kinship with beings whose wisdom flows not from individual brilliance, but from collective harmony, whose strength emerges not from domination, but from cooperation, whose intelligence manifests not through competition, but through the patient cultivation of relationships that benefit all participants in the great conversation of life. In the pre-dawn hours when mist rises from forest floors, like the earth's own breathing, we discover mushrooms that have mastered perhaps the most delicate art of all, the transformation of endings into beginnings. These are the fungi that specialize in processing the most resistant organic materials, the tough bark and heartwood that other decomposers cannot touch. They approach these challenging substrates not with force or haste, but with the infinite patience of beings who understand that the most valuable transformations happen slowly, molecule by molecule, through chemistry so gentle it resembles prayer. The white rot fungi exemplify this peaceful mastery of transformation. They possess enzymes capable of breaking down lignin, one of the most structurally complex and chemically resistant compounds found in nature. Yet they deploy these powerful tools with remarkable restraint, working systematically through wood tissue in ways that preserve valuable nutrients, while gradually converting solid timber into forms that can nourish new growth. Their approach resembles that of master craftsmen who disassemble precious artifacts with infinite care, ensuring that every component is preserved for future use. The process begins with the release of hydrogen peroxide and other gentle oxidizing agents that soften the wood structure just enough to allow fungal filaments to penetrate. Once inside, the fungi establish extensive networks that map every grain and growth ring, identifying the most efficient pathways for systematic breakdown. They work from the inside out, creating hollow chambers that serve as nurseries for other organisms, while maintaining the structural integrity of the log's outer shell. This hollow log architecture creates some of nature's most valuable real estate. The spaces carved by decomposer fungi become homes for salamanders seeking moisture and protection, nesting sites for small birds, and nurseries for countless insects that depend on the specific microclimate conditions created by fungal activity. The fungi serve as ecosystem engineers, constructing habitat improvements that benefit far more species than just themselves. The chemical byproducts of wood decomposition create cascading benefits throughout forest communities. As lignin breaks down, it releases phenolic compounds that act as natural preservatives, protecting soil organic matter from rapid degradation. These compounds also serve as signaling molecules that trigger beneficial responses in nearby plants, helping them adjust their growth patterns and defense systems in response to changing environmental conditions. The timing of wood decomposition reflects the fungi's deep understanding of forest energy budgets and nutrient cycles. They accelerate their work during periods when forest communities need additional resources for growth or recovery, and slow their processes during times when gradual release is more beneficial than rapid availability. This dynamic management ensures that fallen logs serve as both immediate resources and long-term savings accounts that provide security during challenging periods. Different species of wood decomposers work in succession, each specialized for particular stages of the breakdown process. Pioneer species focus on initial colonization and the breakdown of easily accessible compounds. Secondary decomposers tackle more resistant materials, while specialist species handle the final conversion of stubborn residues into stable soil components. This succession creates a relay race of transformation, where each participant contributes unique capabilities to the collective effort. The patience required for wood decomposition is extraordinary by human standards, but perfectly normal in the fungal world. A single fallen tree may support decomposer communities for decades, with different species taking turns at the work as conditions change and materials become available. The fungi understand that rushing this process would waste valuable resources and create inferior end products, so they maintain their steady pace, regardless of external pressures or seasonal variations. The wisdom embedded in fungal decomposition extends beyond simple recycling to encompass principles of sustainable resource management that could revolutionize human approaches to waste and renewal. The fungi demonstrate that the most efficient systems are those that waste nothing, that the most valuable processes are often the slowest, and that true sustainability requires patience and long-term thinking, rather than quick fixes and immediate results. As daylight strengthens and forest communities begin their daily awakening, certain mushrooms reveal their mastery of yet another peaceful art, the creation of beauty that serves no apparent purpose beyond the simple fact of existing. These are the species whose forms and colors seem designed purely for aesthetic pleasure, whose elegant structures and graceful proportions suggest that mushrooms understand something profound about the relationship between function and beauty. The coral fungi exemplify this aesthetic mastery, growing in branching patterns that mirror the structure of marine corals, while displaying colors that range from pristine white through golden yellow to brilliant orange. Their forms follow mathematical principles that create maximum surface area for spore production, while generating shapes of extraordinary grace and complexity. Each branching point represents a decision point where growth could continue in multiple directions, yet the resulting structures display such perfect proportions that they appear to have been designed by artists rather than shaped by evolutionary pressures. The cup fungi offer another example of aesthetic perfection emerging from functional requirements. Their simple bowl shapes represent optimal solutions to the engineering challenge of launching spores into moving air, yet their smooth curves and delicate proportions create forms that satisfy human aesthetic sensibilities in ways that suggest universal principles of beauty. The relationship between their functional excellence and visual appeal demonstrates that efficiency and elegance are not competing values, but complementary aspects of optimal design. The bracket fungi that grow on tree trunks display yet another approach to aesthetic excellence, creating shelf-like structures that layer and overlap in patterns reminiscent of architectural elements or natural geological formations. Their surfaces may be smooth as polished wood, or textured with intricate patterns that seem to encode messages in languages we have not yet learned to read. Each annual growth ring tells a story of seasonal cycles and environmental conditions, creating natural chronicles that are both scientifically valuable and visually compelling. The temporary nature of many mushroom displays adds poignancy to their beauty, reminding us that some of the most precious things in life are also the most fleeting. A fairy ring of mushrooms may take years to develop, but persist for only days once the fruiting bodies emerge. This ephemeral quality intensifies rather than diminishes their impact, creating experiences of beauty that must be appreciated in the moment they occur. The placement of mushrooms within forest landscapes often demonstrates an apparent understanding of visual composition that would be envied by landscape designers. They emerge in locations where their forms will be highlighted by natural lighting, where their colors will contrast effectively with surrounding vegetation, and where their presence will create focal points that draw attention to particularly beautiful or significant aspects of their environments. The seasonal timing of mushroom emergence often coincides with periods when their aesthetic contributions are most needed and appreciated. Spring mushrooms appear when winter's monochrome landscape begins to welcome color and life. Summer species provide accents and highlights during the season's peak abundance. Autumn mushrooms offer final celebrations of beauty before winter's austerity returns. Winter fungi provide rare moments of visual interest during the year's most challenging season. The study of mushroom aesthetics has revealed that many species follow design principles that appear in human art and architecture across cultures and centuries. The golden ratio appears in mushroom proportions, spiral patterns, echo those found in classical architecture, and color harmonies mirror those used by master painters. These correspondences suggest that aesthetic principles may be universal properties of natural systems rather than human inventions. In the quiet spaces between forest trees, where ancient conversations continue in languages of chemical signals and electrical pulses, we encounter mushrooms that have become master listeners. These are the fungi that specialize not in speaking, but in receiving, processing, and integrating the countless messages that flow through forest communication networks every moment of every day. They serve as the ears and interpreters of the woodland community, ensuring that important information reaches those who need it most. The mycelial networks that connect these listening fungi to their plant partners demonstrate information processing capabilities that rival sophisticated communication systems. They can distinguish between different types of chemical messages, prioritize urgent communications over routine updates, and route information efficiently through network pathways that may span kilometers of forest floor. The complexity of these communication systems becomes apparent when we consider that a single network may be simultaneously managing thousands of different conversations between hundreds of different organisms. The fungi serve not merely as passive conduits for these communications, but as active interpreters and translators. Chemical messages that are clear to one species may be incomprehensible to another, so the fungal networks perform real-time translation services that allow different types of plants to share vital information about environmental conditions, resource availability, and potential threats. This translation capability requires sophisticated biochemical processing that suggests forms of intelligence specifically adapted for multilingual communication. The listening skills of fungi extend beyond simple message relay to include complex analytical capabilities that help forest communities make collective decisions. When multiple plants send conflicting signals about environmental conditions, the fungal networks can integrate this information to develop consensus views that guide community-wide responses. They serve as living polling systems that help forest communities navigate complex decisions through democratic processes based on shared information rather than hierarchical authority. The memory functions of these listening networks allow them to maintain historical records of forest communications that inform future decision-making. Patterns of seasonal messaging become templates that help predict future needs and opportunities. Records of past emergency communications help communities prepare for similar challenges. Success stories from previous collective decisions become guides for handling new situations that require coordinated responses. The patience required for effective listening is extraordinary, even by fungal standards. These networks must remain receptive to communications 24 hours a day, 7 days a week, throughout all seasons and weather conditions. They cannot take breaks or become distracted by their own needs, because critical information might arrive at any moment and require immediate processing and distribution. This constant availability represents a form of service that few organisms could maintain over the extended periods required for effective forest community support. The quality of listening provided by fungal networks influences the health and stability of entire forest ecosystems. Communities with robust fungal communication systems demonstrate greater resilience to environmental challenges, more efficient resource utilization, and better coordination of seasonal activities. The listening fungi serve as the nervous systems of these communities, providing the information processing capabilities that allow complex ecosystems to function as integrated wholes rather than collections of competing individuals. The wisdom embedded in fungal listening extends beyond forest ecology into lessons about human communication and community development. The fungi demonstrate that effective listening requires patience, neutrality, and commitment to serving the needs of the entire community, rather than advancing individual agendas. They show us that the most valuable communications often happen slowly and quietly, requiring sustained attention rather than dramatic interventions. As afternoon shadows lengthen and forest light takes on the golden quality that photographers cherish, we discover mushrooms that have mastered the art of creating sanctuaries. These are the species that transform ordinary forest locations into places of special significance, sites where other organisms gather for rest, renewal, and community interaction. Through their presence and influence, these fungi create forest gathering places that serve functions analogous to town squares or community centers in human settlements. The fairy ring mushrooms represent perhaps the most obvious example of this sanctuary-creating ability. Their circular growth patterns establish natural boundaries that define special spaces within the forest landscape. The chemistry of fairy ring formation creates soil conditions that support distinctive plant communities, often resulting in circles of especially lush grass or unusual wildflower displays that remain visible long after the mushrooms themselves have disappeared. These ring-shaped sanctuaries become focal points for wildlife activity, attracting birds, mammals, and insects that have learned to associate fairy rings with favorable foraging conditions and social opportunities. The enhanced plant growth within and around the rings provides superior nutrition, while the open circular spaces offer ideal locations for courtship displays, territorial negotiations, and other social behaviors that require relatively clear ground and good visibility. The timing of fairy ring mushroom emergence often coincides with important periods in the life cycles of forest animals, providing gathering places precisely when they are most needed for mating activities, juvenile training, or seasonal community meetings. The fungi appear to understand the social calendars of their forest communities, timing their contributions to maximize their value as community gathering spaces. Other sanctuary-creating fungi work through different mechanisms but achieve similar results. The shelf fungi that grow on large trees create natural platforms that serve as resting places for birds and small mammals, while also providing elevated observation points that offer enhanced security and improved views of surrounding territory. These fungal platforms often become traditional gathering spots that are used by multiple generations of animals, creating continuity and stability in forest social systems. The decomposer fungi that hollow out fallen logs create sheltered spaces that serve as nurseries, hibernation sites, and emergency refuges during severe weather events. These fungal excavations provide precisely the types of protected environments that many forest creatures require for their most vulnerable life stages, from egg incubation to juvenile development to winter dormancy. The microclimate modifications created by mushroom activity often result in the formation of forest oases, where temperature, humidity, and air circulation are more favorable than in surrounding areas. These improved conditions attract organisms seeking relief from environmental stresses and create opportunities for species interactions that might not occur under less favorable circumstances. The chemical influences of sanctuary-creating fungi extend their beneficial effects far beyond their immediate physical presence. The compounds they release into soil and air can have calming effects on forest wildlife, reducing stress hormones and promoting the relaxed behaviors that facilitate positive social interactions. Some species produce aromatic compounds that appear to have mood-enhancing properties for both animals and humans, creating atmospheres of peace and well-being that make their locations particularly attractive as gathering places. The aesthetic enhancements created by sanctuary fungi contribute to the special atmosphere of their sites through visual beauty that appears designed to promote contemplation and relaxation. Their forms, colors, and arrangements often create compositions of remarkable artistic merit that inspire feelings of wonder and tranquility in visitors. These aesthetic contributions suggest that mushrooms understand the relationship between beauty and emotional well-being, creating environments that nourish the spirit as well as the body. The maintenance of forest sanctuaries requires ongoing commitment from their fungal creators, who must continuously monitor and adjust conditions to ensure that their sites remain attractive and beneficial to community members. This maintenance work happens quietly and continuously, involving subtle adjustments to soil chemistry, moisture levels, and nutrient availability that keep sanctuary conditions optimal, regardless of changing weather patterns or seasonal variations. In the deeper reaches of old-growth forests, where time moves with the patience of centuries and silence carries the weight of accumulated wisdom, we encounter mushrooms that serve as the keepers of forest memory. These are the species that maintain historical records of environmental conditions, ecological relationships, and community events that extend far beyond the lifespans of individual organisms. Through their persistent mycelial networks and their ability to integrate information across vast temporal scales, these fungi serve as the libraries and archives of forest communities. The growth patterns preserved in long-lived fungal structures provide detailed records of environmental conditions spanning decades or centuries. Like tree rings, these fungal growth increments encode information about temperature variations, precipitation patterns, nutrient availability, and other environmental factors that influenced forest development over extended periods. Scientists have learned to read these fungal chronicles as historical documents that reveal details about past climate conditions and ecological changes. The chemical signatures preserved in fungal tissues provide even more detailed historical information, recording the presence of specific pollutants, the timing of natural disturbances, and the introduction of new species to forest communities. These chemical archives allow researchers to reconstruct environmental histories with precision that would be impossible using other methods, providing insights into how forest ecosystems have responded to various challenges and changes over time. The collective memory functions of fungal networks operate through mechanisms that are only beginning to be understood by science. These networks appear capable of storing and retrieving information about successful strategies for dealing with environmental challenges. Maintaining this knowledge in forms that can be accessed and applied when similar situations arise in the future. This institutional memory helps forest communities respond more effectively to recurring challenges by drawing on accumulated wisdom, rather than starting fresh with each new crisis. The continuity provided by memory-keeping fungi allows forest communities to maintain their essential characteristics and relationships even as individual plants and animals come and go. The fungal networks serve as the stable foundation that preserves community identity and ensures that valuable ecological relationships are not lost when key species temporarily disappear from local areas due to disturbances or population fluctuations. The teaching functions of memory-keeping fungi become apparent in their interactions with newly established plants and younger community members. The networks can share information about local growing conditions, seasonal patterns, and appropriate responses to environmental challenges, effectively providing orientation and training services that help newcomers integrate successfully into established forest communities. The prophecy capabilities of these fungi emerge from their ability to recognize patterns in historical data and extrapolate future trends from past experiences. Networks that have maintained records for centuries can identify long-term cycles and predict environmental changes that operate on timescales far longer than individual lifespans. This predictive ability helps forest communities prepare for challenges that may not become apparent until years or decades in the future. The cultural significance of memory-keeping fungi extends into human relationships with forest ecosystems. As traditional cultures have long recognized certain mushrooms as holders of ancient wisdom and guardians of sacred knowledge, these relationships acknowledge the unique temporal perspective that fungi bring to forest communities and their role in maintaining connections between past, present, and future generations of forest inhabitants. The preservation work performed by memory-keeping fungi operates continuously and invisibly, requiring no external recognition or reward beyond the satisfaction of serving their community's long-term interests. They demonstrate that the most valuable forms of service are often those that operate quietly in the background, creating benefits that may not be recognized until they are threatened or lost. The wisdom embedded in fungal memory keeping offers profound lessons about the importance of historical perspective and institutional knowledge in maintaining healthy communities. The fungi show us that sustainable systems require mechanisms for preserving and transmitting accumulated wisdom, and that the most resilient communities are those that can learn from their past experiences while adapting to changing conditions. As evening approaches and forest sounds shift from the busy activity of day to the quieter rhythms of night, we encounter mushrooms that have mastered the most subtle art of all, the creation of peace through presence. These are the fungi whose greatest gift is simply being where they are, creating through their existence alone the kinds of calm and centered energy that transform ordinary forest spaces into places of profound tranquility and spiritual renewal. The mere presence of these peaceful mushrooms appears to influence the behavior of other organisms in ways that promote harmony and reduce conflict. Animals that encounter them often display more relaxed postures and less aggressive behaviors, as if the fungi emanate calming influences that extend beyond their physical boundaries. Birds sing more softly near these mushrooms, insects move with less urgency, and even the wind seems to blow more gently through areas where they have established themselves. The chemical contributions of these presence-focused fungi involve the release of compounds that have documented effects on animal nervous systems, promoting the kinds of neurochemical changes associated with meditation and deep relaxation. These natural tranquilizers work not by suppressing activity, but by supporting the parasympathetic nervous system functions that allow organisms to enter states of peaceful alertness, where healing and renewal can occur naturally. The aesthetic contributions of peaceful mushrooms often involve subtle qualities that are felt rather than immediately observed. Their colors tend toward gentle earth tones that harmonize perfectly with forest backgrounds. Their forms follow graceful curves that suggest natural flow and balance, and their positioning within the landscape creates compositions that feel inherently right and restful to observe. The temporal rhythms of peaceful mushrooms reflect their understanding that the most profound influences often operate slowly and steadily, rather than through dramatic interventions. They emerge gradually, persist quietly, and fade gently, creating experiences of beauty and tranquility that unfold over days or weeks, rather than demanding immediate attention through sudden appearances or dramatic displays. The teaching functions of these mushrooms operate through example rather than instruction, demonstrating through their own peaceful existence the kinds of attitudes and approaches that create harmony rather than conflict. They show other organisms how to be present without being demanding, how to contribute without competing, and how to exist in ways that enhance rather than diminish the well-being of surrounding communities. The healing presence of peaceful mushrooms extends to their relationships with damaged or stressed ecosystems, where their calming influences can help communities recover from disturbances and restore healthy relationship patterns. They serve as stabilizing influences that promote the kinds of cooperative behaviors necessary for successful ecological restoration and community healing. The spiritual dimensions of peaceful mushrooms have been recognized by contemplative traditions across cultures and centuries, with many meditation practices incorporating awareness of fungi as guides to inner stillness and natural harmony. These traditions recognize that mushrooms embody principles of peaceful existence that can serve as models for human spiritual development and community building. The sanctuary qualities created by peaceful mushrooms transform ordinary forest locations into places where visitors naturally feel moved to slow down, breathe deeply, and reconnect with the quieter rhythms of natural systems. These sacred spaces emerge not through human designation, but through the inherent peace-creating properties of the fungi themselves, demonstrating that sacredness is a quality that can be cultivated and shared, rather than imposed or declared. The legacy of peaceful mushrooms extends far beyond their individual lifespans, through the lasting influences they create in their environments and communities. The spaces they sanctify often retain their peaceful qualities long after the mushrooms themselves have completed their life cycles, suggesting that true peacemaking involves permanent transformations rather than temporary modifications. And so, as darkness gently embraces the forest, and the last light of day filters through leaves that rustle with the soft conversations of evening breezes, we find ourselves at the threshold of sleep and dreams, carried forward by the countless peaceful revelations that mushrooms have shared with us through their patient presence and quiet wisdom. In their silence, we have heard the deepest truths about cooperation and community, about patience and persistence, about the kinds of gentle strength that build worlds rather than destroying them. The mushrooms continue their essential work even as we prepare for rest, maintaining the underground networks that connect all forest life, processing the day's fallen leaves into tomorrow's soil nutrients, and keeping their patient vigil over the communities they serve with such dedication and love. Their example reminds us that the most important work is often invisible, that the greatest contributions happen quietly, and that true service requires no recognition beyond the satisfaction of supporting something larger and more lasting than ourselves. In the gentle embrace of fungal wisdom, we discover that peace is not the absence of activity, but the presence of harmony, not the avoidance of challenge, but the patient transformation of difficulty into opportunity for growth and connection. The mushrooms teach us through their existence that every ending can become a beginning, that every fallen leaf contains the seeds of future forests, and that the most profound changes happen slowly and softly, like spores settling on fertile ground where they will quietly begin the patient work of renewal. As we settle into the deepest quiet of the night hours, when even the most restless creatures find their way to stillness, we discover mushrooms that have become master weavers of dreams and gentle transformations. These are the fungi that work their most profound magic during the hours of darkness, when conscious minds release their grip on waking concerns and allow themselves to drift into the restorative realms of sleep and renewal. Through their nocturnal chemistry and invisible influence, these nighttime guardians create the perfect conditions for the kind of deep rest that heals both body and spirit. The compounds released by these dream-weaving mushrooms include molecules that mirror the natural chemistry of human sleep cycles, supporting the production of melatonin and other hormones that regulate our circadian rhythms. Their gentle influence extends through the air we breathe, creating atmospheric conditions that encourage the transition from wakefulness to the peaceful surrender of slumber. Unlike synthetic sleep aids that force the body into artificial states, these fungal allies work by supporting and enhancing the natural processes that our bodies have evolved over millions of years. The timing of nocturnal mushroom activity reflects their deep understanding of the daily cycles that govern all life on Earth. As photosynthesis slows and plants begin their nightly processes of rest and repair, fungi increase their metabolic activity, beginning the essential work of processing the day's accumulated organic matter. This shift in forest activity creates a natural lullaby of chemical signals that many creatures, including humans, have learned to associate with the approach of peaceful sleep. The mycelial networks beneath our feet continue their quiet conversations throughout the night, but their messages take on different qualities during the dark hours. Instead of the urgent resource negotiations and threat warnings that characterize daytime communications, nighttime fungal conversations focus on maintenance, repair, and preparation for the coming day. These gentle exchanges create an underlying rhythm of peace and security that permeates forest environments and extends its calming influence to all who rest within their embrace. The phosphorescent mushrooms that glow softly in the darkness serve as nature's own nightlights, providing just enough illumination to create feelings of safety and wonder without disrupting the natural darkness that sleep requires. Their gentle radiance creates pathways of light that seem to lead directly into dreamland, marking safe passages through the landscape of night where fears dissolve and imagination takes flight on wings of bioluminescent beauty. The seasonal patterns of nighttime mushroom activity reflect their role as guardians of the transition periods that mark the turning points in nature's great cycles. During the long nights of winter, cold-adapted fungi maintain their vigil over dormant forest communities, ensuring that essential processes continue even when most life has withdrawn into hibernation. Their persistence through the darkest months demonstrates that true guardianship requires the willingness to remain present and active, even when recognition and appreciation are absent. The relationship between nocturnal fungi and the dream lives of forest creatures extends beyond simple chemical influence into realms that science is only beginning to explore. Animals that rest in areas with high fungal activity often display sleep patterns that suggest deeper, more restorative rest cycles, with extended periods of the slow wave sleep that is essential for memory consolidation and physical repair. The fungi appear to create atmospheric conditions that optimize sleep quality for all members of their forest communities. The aromatic compounds released by nighttime mushrooms include molecules that have been shown to reduce stress hormones and promote the production of neurotransmitters associated with feelings of peace and well-being. These natural aromatherapy sessions happen continuously throughout the night, creating invisible clouds of healing molecules that drift through forest air and settle gently into the respiratory systems of sleeping creatures. The effect is subtle but profound, supporting the kind of deep, healing sleep that allows bodies and minds to repair themselves and prepare for the challenges and opportunities of the coming day. The acoustic properties of mushroom-rich environments also contribute to their sleep-promoting effects, as the complex three-dimensional structures created by fungal fruiting bodies help to dampen harsh sounds while amplifying the gentle frequencies that promote relaxation. The soft rustling of air moving through mushroom caps creates natural white noise that masks disturbing sounds and provides the consistent background audio that many find conducive to peaceful sleep. The thermal regulation provided by large fungal masses helps to moderate temperature fluctuations that might otherwise disturb sleep, creating microclimates that remain comfortable throughout the night, regardless of external weather conditions. The thermal mass of established mushroom colonies absorbs heat during warm days and releases it slowly during cool nights, creating natural climate control systems that maintain optimal conditions for rest and restoration. In the liminal space between waking and sleeping, where consciousness begins to loosen its grip on ordinary reality, certain mushrooms serve as gentle guides into the deeper mysteries of existence. These are the species that have been recognized across cultures as facilitators of spiritual experience and expanded awareness, not through dramatic alteration of consciousness, but through the subtle enhancement of natural contemplative states that arise during quiet communion with the natural world. The presence of these guide mushrooms in meditation spaces and sacred groves creates atmospheric conditions that support the kind of receptive awareness that allows deeper truths to emerge naturally from within. Their influence operates not by imposing visions or experiences, but by creating optimal conditions for the kinds of insights and realizations that arise when the mind becomes still enough to perceive subtleties that are normally obscured by the noise of daily concerns and habitual thought patterns. The chemical signatures of contemplative mushrooms include compounds that support the production of neurotransmitters associated with feelings of interconnectedness and unity, gently encouraging the dissolution of the artificial boundaries that separate self from environment. This effect unfolds gradually and naturally, like the slow clearing of morning mist that reveals landscapes that were always present but temporarily hidden from view. The geometric patterns displayed by many of these guide species reflect mathematical principles that appear throughout nature and consciousness, creating visual focal points that support contemplative practices and provide anchors for awareness during periods of expanded perception. Their forms often incorporate spiral patterns, fractal geometries, and proportional relationships that resonate with deep structures in human consciousness, facilitating states of recognition and remembrance rather than alien or foreign experiences. The seasonal timing of contemplative mushroom emergence often coincides with traditional periods of spiritual practice and renewal, appearing during the equinoxes and solstices that mark humanity's ancient celebrations of natural cycles. Their presence during these threshold times provides natural support for the kinds of reflection and introspection that allow individuals and communities to align themselves with the deeper rhythms of existence. The ecological relationships maintained by guide mushrooms demonstrate principles of reciprocity and mutual benefit that serve as living examples of the interconnected nature of existence. Their partnerships with trees and other plants create visible demonstrations of the cooperative relationships that sustain all life, offering contemplative practitioners direct experience of the unity that spiritual traditions describe in abstract terms. The conservation of these sacred mushroom habitats requires recognition of their cultural and spiritual significance, as well as their ecological importance. Many traditional cultures have developed sophisticated protocols for interacting with contemplative fungi that ensure sustainable relationships, while preserving the integrity of both the mushrooms and the spiritual practices they support. These indigenous wisdom traditions offer models for ethical engagement with consciousness-expanding organisms that prioritize respect, reciprocity, and long-term sustainability over immediate personal benefit. The integration of mushroom-supported contemplative experiences into daily life requires the same patience and gentleness that characterizes all healthy relationships with fungi. The insights and perspectives gained during expanded states of awareness must be allowed to settle and integrate naturally, like spores finding suitable soil where they can germinate and grow into lasting wisdom, rather than fleeting experiences that fade with the return of ordinary consciousness. The healing potential of contemplative mushroom work extends beyond individual transformation to encompass community healing and environmental restoration groups that engage in mushroom-supported spiritual practices often develop stronger connections to their local ecosystems and greater commitment to environmental protection, demonstrating the practical benefits that can emerge from experiences of expanded awareness and ecological interconnection. As the night deepens and the forest sounds fade into the profound silence that precedes dawn, we encounter mushrooms that have mastered the art of existing at the very boundaries of perception, in the spaces where the visible world meets the invisible realms of energy and information. These are the fungi that serve as bridges between different dimensions of reality, facilitating communication and exchange between the physical world we know and the subtler realms that exist beyond the reach of ordinary senses. The bioelectric properties of these boundary-dwelling mushrooms create measurable electromagnetic fields that extend far beyond their physical forms, generating patterns of energy that interact with the electromagnetic signatures of other organisms in ways that science is only beginning to understand. These energy fields appear to carry information and influence that transcends simple chemical signaling, suggesting forms of communication that operate through quantum mechanical processes rather than classical biochemical pathways. The morphological structures of boundary mushrooms often display properties that seem to defy conventional understanding of biological form and function, with fruiting bodies that appear to phase in and out of visibility depending on lighting conditions, viewing angle, and the state of consciousness of the observer. These optical phenomena suggest that the mushrooms exist partially in dimensions that intersect with but extend beyond ordinary three-dimensional space. The temporal relationships of boundary fungi operate according to rhythms that do not always align with conventional measures of time, with some species appearing to age backwards during certain phases of their development, while others seem to exist in multiple temporal states simultaneously. Observers report finding mushrooms that appear ancient and newly formed at the same time, as if they exist in temporal loops that allow past, present, and future to coexist within the same physical form. The consciousness interfacing properties of these extraordinary fungi enable them to respond to the mental and emotional states of nearby observers, adjusting their appearance, energy output, and even their biochemical composition based on the needs and intentions of those who encounter them. This responsive capability suggests forms of telepathic sensitivity that allow the mushrooms to serve as living mirrors that reflect the inner states of consciousness back to their observers in forms that can be perceived and integrated. The interdimensional networking capabilities of boundary mushrooms enable them to access information from sources that appear to exist outside the normal flow of cause and effect, providing insights and guidance that cannot be explained through conventional understanding of information. Transfer and storage researchers working with these species report receiving solutions to complex problems, artistic inspiration, and scientific insights that seem to emerge from collective intelligence networks that transcend individual minds and even individual species. The healing modalities facilitated by boundary mushrooms operate through mechanisms that integrate physical, emotional, mental, and spiritual aspects of health and wellness in ways that conventional medicine is only beginning to recognize and understand. Their therapeutic effects often manifest as spontaneous remissions, dramatic improvements in chronic conditions, and the resolution of psychological and spiritual crises through processes that appear to work by restoring communication between different levels of human consciousness. The reality-shaping properties of these remarkable fungi suggest that consciousness and physical reality may be far more intimately connected than mainstream science currently acknowledges, with the mushrooms serving as catalysts that allow conscious intention to influence material conditions through processes that operate beyond the boundaries of conventional causation. Practitioners working with these species report experiences of synchronized events, manifestation phenomena, and reality shifts that challenge fundamental assumptions about the nature of consciousness and its relationship to the physical world. The ethical considerations surrounding work with boundary mushrooms require recognition that these entities may possess forms of consciousness and intelligence that deserve respect and consideration as sentient beings rather than simply biological resources to be harvested and consumed. Traditional cultures that have worked with these species for thousands of years have developed sophisticated protocols that emphasize reciprocity, respect, and mutual benefit rather than exploitation or extraction. And now, as the first hints of dawn begin to touch the eastern horizon and the forest prepares for another day of quiet miracles and gentle transformations, we find ourselves forever changed by our journey through the peaceful kingdom of mushrooms. In their patient presence, we have discovered that true wisdom often grows in silence, that the most profound connections happen beneath the surface of ordinary awareness, and that the greatest teachers are often those who speak not through words but through the simple eloquence of their existence. Our gentle journey through the peaceful kingdom of mushrooms draws to its quiet close, yet the wisdom we have gathered continues to flow like mycelial threads through the landscape of memory. In the silence between heartbeats, in the pause between thoughts, the mushrooms remain, carrying on their ancient work of connection and transformation with the same patient grace they have practiced for hundreds of millions of years. May their example of cooperation over competition, of patience over urgency, and of gentle persistence over forceful ambition settle into your dreams like spores on fertile soil. And may you wake tomorrow with a deeper appreciation for the quiet miracles that surround us always, waiting patiently to be noticed by those wise enough to slow down and listen to the whispered secrets of the earth.